I'm Nate Spack, and today I'll be presenting on Chapter 7, Segment 2 of the Psychology textbook. So, biological rhythms enforce a sleep-wake cycle. So, a biological clock is a biological mechanism in animals that keeps track of time, and our circadian rhythm is the cycle of activity and rest in an animal and in us as well that lasts about 1 day. The suprachiasmatic nucleus is a region of the hypothalamus that controls the circadian rhythm, and tiny lesions in the SCN inhibit animals' circadian rhythm under constant dim light. Now finally, jet lag is just the disruption of circadian rhythms caused by rapid travel across time zones. Now there are two different categories of sleep. There's REM sleep and there's non-REM sleep. However, we're going to start with an electroencephalogram, or an EEG. This is just how we measure fluctuating potentials in the brain, and a desynchronized EEG, also known as beta activity, is a pattern of EEG activity comprising of a mix of many different high frequencies with no dominant frequency and with low amplitude. Stage 1, Stage 2, and Stage 3 sleep are the stages of non-REM sleep, and so Stage 1 is the initial stage of sleep in which the EEG shows small irregular waves and characteristic sharp waves called vertex spikes. The next stage, Stage 2 sleep, is the stage defined by sleep spindles and K complexes. Sleep spindles are a train of small spikes in the EEG, and K complexes are large single spikes in the EEG. Finally, we have Stage 3 sleep, also known as slow wave sleep, and this stage is defined by the presence of large amplitude slow waves. These waves are commonly referred to as delta waves, and these are the most prevalent type of brain wave in Stage 3 sleep. Now, rapid eye movement sleep, also known as paradoxical sleep, is a stage of sleep characterized by desynchronized EEG, flaccid muscles, and rapid eye movements. And the only reason we don't awaken and act out our dreams is because we are paralyzed during REM sleep. And non-REM sleep is just sleep stages 1, 2, and 3, as I previously mentioned. So do animals dream? So mammals and birds are perfect animals for us to study with regards to sleep because they both display REM and slow wave sleep. And we can apply these conclusions to humans because their sleep patterns are very similar. From these studies, we found that the subceruleus is a region in the brainstem that inhibits motor neurons during REM sleep. In a study, cats would awaken and act out their dreams during REM sleep when the subceruleus was lesioned. And REM behavior disorder, or RBD, is a syndrome primarily afflicting middle-aged men where movements are made during REM sleep that seem to correspond to movements taking place in the current dream. Now, this is thought to impact the subceruleus of the brain. Now, at least 4 brain regions regulate sleep states. Now, one of them, the basal forebrain, is responsible for slow wave sleep, and lesions in this region lead to insomnia. The reticular formation is an area in the brainstem that's responsible for waking. Now, the subceruleus is the REM sleep center. Narcolepsy is a disorder causing a person to have intense attacks of sleep lasting from 5 to 30 minutes during usual waking hours. They can also randomly get flaccid muscles while they're performing any normal daily task. And hypocretin is a neuropeptide found almost exclusively in the hypothalamus, which is responsible for coordinating the transition from one sleep state to another. And hypocretin releasing neurons in the hypothalamus send axons to each of the 3 brain regions responsible for each sleep state. This is strong evidence to suggest that hypocretin has a very large impact on sleep. Now, we need sleep, but why? So one reason is niche adaptation. Natural selection favors organisms that specialize to fill an ecological niche, and sleep is a part of this. In particular, whether you're diurnal or you're nocturnal, this plays a big role in what ecological niche organisms fill. And another reason we need sleep is for energy conservation. And sleep conserves energy and burns less calories and also helps conserve body heat. This is why small mammals need more sleep than larger mammals, because they have a hard time conserving body heat, so sleep helps them conserve this body heat. Now, memory consolidation is also a beneficiary of sleep, and now sleep helps in the memory of a wide range of tasks, and REM sleep may aid learning, but however, it's not absolutely necessary in order to learn. And finally, body restoration. Since total sleep deprivation is indeed fatal, sleep must restore the body in some way. I'm Nate Spack, and that's my presentation.